Chapter 12 of Interactive Statistics Methods is on hypothesis testing. This is the final chapter of the book. It wraps up everything that you've learned up to this point and brings us full circle in our workflow of trying to understand what statistics is, what it means in the context of the larger arena of research methodology, research design. That is a component of that for the analysis and display of data. And this last and final chapter has our odd icon, so you want to be very familiar with this. So we return to our hypothesis testing methodology and breaking down exactly what are the various forms of hypotheses, scientific hypotheses. A research hypothesis, the null hypothesis, the alternative hypothesis, the expression of it as H sub 0 and H sub A, and then explaining it later on as mathematical hypotheses as H sub 1 and H sub 0, respectively. Much of this chapter is dedicated to explanation, so it's very expository in the narrative and in the text. Read through it. It's going to go back, cover a lot of the things that you've already seen, give you an example such as this graph that has a population, extracting a sample, and then going into an experimental research designs. What are the various types of samples, types of experiments that you find that are often talked about? Going back to some of the statistical measures, what's an outlier, probability, population density. So we're wrapping all of this back together so you have a better understanding of statistics as a whole, how it all fits together, why you're doing what you're doing, answering the big question by reading through here. And you've been introduced to the various parts, but putting the parts together so you can see it in the whole now. And now, what are the defining definitions that are commonly used to describe research designs and statistics in particular? Okay, at this point, here we are talking about the null hypothesis as H sub 0. Back to alpha and beta error. What is the decision rule and how do we chart it? Okay, H sub 0, H sub A, which we know, of course, becomes H sub 1. The possibilities of a type 1 or type 2 error, and the right decision in a chart form. A model illustrating the process of hypothesis testing. A model illustrating further the breakdown of the hypothesis test. A model emphasizing how to go about building your research design from the beginning, clarifying the hypothesis test, all the way down to the types of sample and then how to take a look and select your tests. 7 steps to building from the research design of the null and alternative hypothesis, which is your initial research hypothesis, into sample mathematical hypotheses based on your statistic that you've used to analyze the data that you extract from the sample, which was, of course, taken from the population, so you can take that data and the inferences that you gather and the information and take it back to the population. Example using chi-square when it's so close that you don't get a level of significance. Important to see what it's like when you're not able to conclude that, because you're not always going to be able to do that. It depends on the data that you get. All right, types of qualitative data, which is the opposite of quantitative data, but they can be used together. Your design methodology. How do you go about the structure from beginning to end in statistics? Sampling. There's many different types. Again, in social behavioral sciences, we have to have these types because often the protocols for an educational institution or other places are not convenient for actual core research design. You can't put people in the petri dish. You just experiment on them. You're violating the law. So we have to be aware of that. How to select your sample sizes. What is significance and what does it really mean? So as we're scrolling through this, this is just explaining everything to you concisely. And we end once again with our charts, just explaining to you what hypotheses are. When is it directional? When is it non-directional? When is it feasible? What's the definition of it? What does it mean? And when you see these various types of hypotheses presented in these mathematical values, and what do these values mean? Okay, what test statistics should be used when you see these types of mathematical hypotheses presented the way they are? So when you go through and very carefully and you look and read through all this, it should condense everything that you've learned in the previous 11 chapters together in your head. And it should help you to understand. So the chapter concludes with your statistics tables. And this is what you refer to based upon, let's take a look here at the one for the standard Z. Well, I want to go a bit further. I want to go to a true test. So here is the t-distribution. So you have your degrees of freedom here, 0.5. And depending on the size of it, then you just come down to 0.5. If I have 8, then my calculated value is going to be, it has to be significantly greater than 2.306 at 0.5. If it's 0.2 or 1, there's your various. For whatever the reason that you select those particularly stringent chances of not being able to reject the null hypothesis or an alpha error, those are at the top. And you'll find those there. So chi-square, F calculations. And I put them actually in a more matrix form because it's easier to go down rows and columns. When in more traditional in other books, you really don't have that. They try to tighten up and put as many numbers as possible in the table. But here, you have them in a row and column, so it's easy to go across and see exactly what your value is. And that's why the tables look that way. And we end, of course, with our references for further study and your index. And this concludes Interactive Statistics Methods.